So this time around, we're going to be talking about recursive backtracking, and I think we're still going to follow this outline. And the first thing that we're going to talk about is going from iterative code to recursive code. And so let's get started with that. A little forward, a little preface to exactly what recursion is and why we need it. So in programming, you often need loops, and so there are ways of writing while loops and for loops, as you can see right here, a while loop. Recursion is the same concept. It's to allow you to do something over and over again for a defined limit, but recursion sometimes makes it a little bit easier to write out your logic by calling functions that call themselves. We'll get into that, but again, the Zybooks and other videos on YouTube can also help, and Geeks for Geeks are very good sources for information if you don't understand what I'm saying here. All right, so let's get started. Let's jump right into our iterative function, and we can define it as it's summing a list of numbers. I wrote a while loop so I could be more verbose and I can kind of show you exactly what's happening with this function. So the first thing is I define the sum, which I will later return. Now don't get daunted by the whole underscore right there. That just represents that this is not the sum function. It's actually a variable named sum, and we want to be descriptive with our variable names. So we have sum over here, and then we have index, which is another variable that stores what index we are at in the nums list. So I'm going with the while loop, and then the concept of this whole function is that we're going to add as we go. Now this is really some simple function, but I want to draw your attention to some of the more important lines that will be, I guess, mimicked in our recursive function. So that'll really help. So the first thing that I want you guys to look at is index is less than the length of num. So this is saying make sure that this thing keeps running as long as index is smaller than the length of nums. And so that will help us go through. Again, this code may have syntax errors and stuff. I haven't run it, but it's just to help you guys get a better understanding of what's going on. So keep this in mind. Then we move into our step, the first step that we do, and that is the sum is equal to the sum plus the number at that index. And so that's very important, and so keep that in mind, and then we increment our index. Pretty cool, right? Awesome. And then finally, once we're done with the while loop, and I think my spacing is all correct, once we're done with the while loop, we return the sum. Great. So let's move on to our recursive function. And so our recursive function is going to be very similar. And so we named it sum rec for sum recursive. Okay. And we pass in just a list of numbers once again. Now, for recursion, sometimes we do call a helper function to help us achieve some of the things that we wanted to do. So in this case, I called a helper function that took in two extra parameters actually. One that is the current sum, so like the sum, and then one that's the index. And this is very similar to this. So this is what we call kind of like setting up, right? So before you can do anything, you want to set up, right? Before you can start coding, you have to like open your coding, whatever, like idle or whatever it is, or Sublime Text for me, right? So before you do that, before you can get into a recursive function, or before you can even do anything in even a while loop, you need to start a kind of setup. And so you can see these are repeated. Now, you can also add parameters here, and then you don't have to repeat them, but just for the sake of like continuity, we didn't do that. Cool. So then we call our helper function, and it takes in nums, which is right here. Again, same nums, right? Takes in sum, again, similar sums, right? And then index, right? And so you can start to see the parallelism between iterative functions and recursive functions. Great. So we've got our helper function, and now we're going to kick it off and get into the actual recursive function. Great. So before we get into recursion, I just want to mention that there are a couple things that you need to always worry about when you are writing recursive functions. And these are kind of steps that will help you guide your thoughts. And so the first thing that you want to do is always think of your base case, right? And so base cases are kind of difficult to come by. They're like, how do I know when to stop? That's the question you should be asking, when to stop. And so when to stop is very, very similar to this, right? This is when to continue going. Now we just got to like negate it or just do the opposite of it, right? And so for this one, I said, okay, if the length of, if index is equal to the length of the number, like the length of the list, then we're going to return the sum. Again, syntactically, my code may not work. I haven't run it, but this is just an exercise in how to write and think about recursive functions. Cool. Moving forward. So this is our base case. This is something kind of intuitive right now, but it may get more and more difficult, but you always need a base case. If you don't have a base case, then you will hit, or if your base case is not good enough, you may hit the dreaded max recursion depth reached or something, right? That Python gives you. So, so definitely always worry about your base case, and this will more often than not help you out in your program. Great. So we talked about a base case. Let's talk about what recursion is. So recursion, again, moving around. What we want with recursion, the first thing that we want to do is we want to think of our first step, right? So our first step. And then after that, we'll think of our subsequent steps. So if this doesn't make sense, let's talk about it and we can kind of get through it. So our first step is adding to sum, right? Just like how we did over here, we're adding to sum, okay? Then our subsequent step, so this is going to be our first step. Let me try to denote that, right? And then we have to, so this is the actual doing, the thing that we wanted to do, right? The thing that we did in the while loop, the thing that we want the recursive function to do, these are the same, right? Okay, that's the logic. But now how do we get it to keep doing until the end? Well, we have to do, and this is going to be known as the rest of the steps, the subsequent steps, the rest of the steps. And so that's where we increment the index so that we keep moving forward, right? If you don't, then it's just going to keep calling itself on, it's going to keep calling it on the same index, right? It's going to be like, let's say, for example, over here, it's going to get stuck at 1. It'll be like 1 plus 1 plus 1 plus 1. And it's never going to reach our base case, and then we'll reach that max recursion depth, right? So this is our first step. And then the rest of the steps, we increment it, and then we call the function again. That's pretty cool, right? We'll just jump back up, right? And then we'll do it again, and we'll do it again, and we'll do it again until we reach the very end. That's pretty cool, in my opinion. All right, so that's how recursion works. So let's just talk about let's just recap real quick. If you get stuck, you can always write an iterative function for some of the smaller things, and then think about how to write it in a recursive way. Recursive functions always have a base case. And this base case is the most important part of the function. This is what tells the function to stop. Then you have your first step, which is the actual logic, the meat of the function. Then you have your subsequent steps, which calls the function itself, right? Then let's just wrap up by saying that there are often times when you need extra parameters, right? You can't, where does sum go? You want to store sum for this example, right? You want to store index for this example. Well, where does it go? So we can store that in the parameters right here by making another helper function. That's pretty cool. And you can start to see the parallels between iterative coding and recursive coding. And this recursion could actually help you achieve a lot, as we will start to see in our next bit. So we talked about being able to go from iterative to recursive code. Let's trace some recursive code. So the best way to trace recursive code is to just get into it, right? So here's our test case, and then this is where we're going to be calling. So we're going to say, let's say, sum rec, right? We're going to call the recursive function, and we're going to pass nums in it, right? So what we're going to do is we're going to pass 1, 2, 3 into this, and so that's going to be passed right here. Along with that, sum is going to be equal to 0, and index is going to be equal to 0. So sum is going to be index 0, and index is 0. We step into here, and we say, okay, and I will try my best. Let me open up a new screen, and I can kind of keep track. Hopefully I can jump back and forth. So over here, we've passed in nums. So let's keep track of nums, and nums is going to be constant because we're not editing nums, right? So we're going to keep nums 1, 2, and 3. Okay? Then we're going to keep track of sum and index. So right now, in our first step, and I'm going to type in 1, so step 1, our first step is going to have this value. Cool. So now, and then we're going to call our function, and so we're going to say sum rec, and we're going to pass in nums. So nums, let's just assume that it's always passed in, right? So or sorry, we're going to call help, not sumrec. Sumrec is just our kickoff function, right? We're going to call help, which is the actual recursive function. And so sum is going to stay constant, so I'm not going to type it, right? But you'll notice the nums is right here. Sum will be passed in as, so this is our first time round, so 0, and then index is going to be passed in 0. Great. Now we're going to run into this function. In fact, let me do this. Let me try and move it right here. Okay. And then bear with me for just 1 second. And there it is. Cool. So what we can do is, this is our first step, right? We call that helper function. Great. Let's jump into it. So we're going to say sum is equal to, right? Sum is equal to sum plus nums of index 0. So sum is equal to 0, right? Because 0 was the original thing. So 0 plus, and then we're going to say, what's the 0 at the index? It's going to be 1, right? And then index, right, will equal, because we just incremented by 1, it's going to now go from 0, so 0 plus 1. Cool, cool. Okay, and then we're going to call our function again. So this is our thing. So this is going to be like step 2, like this. And then we're going to call our function again, copy that, paste it there. But this time round, sum is 1, index is 1. Cool. And then we can keep going. And you can feel free to fast forward this part if you get it. We'll say, and then we're just going to copy this whole thing. And this time round, you start to see exactly what's happening. And you can see when I'm copy pasting, right? It's the same sort of idea as doing a loop. So we got 2 over here, you know, and then index is going to go from 1 to 1 plus 1. So now it's going to become 3, right? Because 1 plus 2 is 3. And then we're going to get this one as 2. And it's going to call the function again. And I often like to just kind of move my cursor around the function as it gets called, right? Line by line. So we'll go over here. Okay, so we get called over here, right? We get the help gets called. We jump here. We don't meet the base case yet. Okay, cool. Let's do the first step. That's right here. Okay, cool. Let's move on to there. That's right there. I hope you can see. Right? And then we go into this, and then we go into this. And then this gets called, so we get jump back up here. And then we move. Oh, the base case isn't met yet. We move into here. And then you'll start to see, as we get over here, we're almost done, right? We can just do another step. Right? Copy. Oh gosh. Copy, paste, and this becomes step 4, and then this becomes, what is it, 3 plus 2 plus, so this is going to become, my God. Should maybe take typing lessons, right? 3, and then this is going to become 1 plus 1 plus 1, and so we'll get 6, and then we'll get index at 3. Cool. Len nums is equal to index, so this gets called again, and then we return sum. And so returning sum will return sum, which is equal to 6. And isn't that the answer? 1 plus 2 plus 3 is equal to 6. So yeah, that's kind of how I like to do it, and this is how you can test. This is pretty cool, this is pretty powerful, and it's a little different than a while loop, right? So you take that as you will. Let's move on to, I guess, the more complicated stuff. So we just covered being able to go from iterative code to recursive code. We were able to trace recursive code, and then we were able to, given an algorithm, write the recursive version of that algorithm. So if you're given this, then you can do this. So you have all of this covered, right? Let's go into some more complicated topics. So permutation, combination, all subsets, memoization, and backtracking. So let's go into backtracking, because that seems to trip a lot of people up. So I'm going to put up a little photo, and I can kind of explain what's happening with backtracking. Actually, let me put up this photo. So the idea of backtracking, and it's just a fancy way of saying, why don't we explore all the paths? And so with backtracking, you have a couple of goals, right? So you can either find a path that leads to success, you can find all the paths that lead to success, or find the best path that leads to success, okay? So this is from the internet, by the way, and so thanks to CS307 Fundamentals, thank you. But the idea of recursive backtracking is that inside your recursive function, you want to open up all of the different paths. So let's say that you had 3 different options, right? you want to explore all of the options, right? And so you go over here and you explore the first option, and that leads you to a dead end. Then you explore the second option, and that option has a couple more options, right? And then you're over here on the last option, and that has some more options, right? And so the idea is that you explore all of these paths, and they open up like this. And when you reach a dead end, that path sends like a message back to the beginning saying that this path isn't viable. We can't do this path. Like this path leads to a dead end. It doesn't get me to where I want, so therefore it's not good, right? So we can't follow that path. That's not the success path, right? Just like how these guys are saying, it's not the success path. So we move over here, and we move along all of these different routes. And so the more routes we move, the more we get along. Now, again, they're saying that not all problems are exactly alike, but the concept of having all these paths is really great. And so you can apply this to a variety of different problems. And I guess we can go over some of the assignments, but before we do that, we can look more at this. And so just let's ignore the top part of this picture, but focus on this tree-like structure. This is known as a tree. This can also be represented as paths. You've got the start, and then you're moving down these paths. And the idea is that you move down all of these, and you get to a certain point, and you're like, okay, this isn't going to work for me. So I'm going to cut this option out, and this is the option that works better. Okay? One of the most, so I guess we can talk about some of the assignments. And so I will jump right here into programming assignments. You've got from assignment 8 to 13. Yes, those are the ones. 8 to 13 are the ones that we covered in this. This is your first recursion exercise. So we kind of talked about that in the first half of this video. And then in this is more about recursive backtracking, stuff like that, group sum 6, stuff like that. So this is on your second half of the video. This is the current half. One thing that I wanted, this is 9, sorry, 10. One thing that I want to, not this one, where is 11? One thing that I want to attract your attention to is the 8 queens problem. This is a recursive backtracking problem in the sense that you want to, I guess, place the queens in the right position so that they're all safe, right? And so you want to recursively backtrack, as in you pick one path, you place the queen in the first position, right? And then a couple of paths open up. And so then you place the queen, you follow all those paths and see if you can place those queens in the right positions. And so that can be accurately represented. And this, if you don't understand this, there's a really good written up tutorial right here on recursion and backtracking. And again, I will link this below, but this will help you figure out how recursion works. So right here, they kind of talk about recursion and how it goes, and factorial is one of our big recursion things. And the idea is that you're breaking it into a smaller problem, right? You're saying, okay, x times x minus 1, and you're doing this whole like go to 0. And the idea is, in recursion, I also like to think of recursion as like you're asking the computer a question, right? So you ask the computer, hey, factorial of, in this case, 5, right? And so the computer's like, great, I know the answer to that, but the answer requires me to ask myself a question. And so the computer says, okay, let me ask x times factorial minus 1, and so that's what happens here. And so that's kind of how the stack works. And you push that thing onto the stack, and then the next question gets asked, that gets pushed onto the stack, that gets pushed onto the stack, that gets pushed onto the stack, and so on and so forth until you get to factorial 0, which they have defined as our base case. And then that says, okay, I have the answer to 0. Great, I can tell 1 that I have the answer, factorial of 1. And then factorial 1 has that answer, right? Because it'll be 1 times 1, 1, right? As you can see right here. And then they'll say, okay, great, we have the answer, let's tell 2, and then 3, and then 4, and then 5, and then at the end we get this whole thing, right? That's pretty cool, right? And so that's the idea of recursion, and then recursive backtracking is very similar. It just takes way more paths. So again, you can read up more about this, and they will explain exactly how it works. But here is backtracking, and then backtracking for the n queens problem, which is a very, very common and important recursive backtracking problem. So the idea here is that you can place this at 1, 1, right, or 0, 0, or whatever, right? You can place this at the top. And the next thing that you want to do is you want to place the second queen. You want to place it somewhere safe. And then you want to place it somewhere safe. And the third queen, you want to place it somewhere safe. And then you realize, okay, there's nowhere else to place the fourth queen. We want to place 4 queens on there. There's nowhere else that they'll be safe. So that path is effectively invalid. Let's go back here, over here. That path over, let's say it's one of these paths, that path is invalid, right? You place the first one, you place the second one, you place the third one, you couldn't place the fourth one. So that path is invalid, right? So then we go and we say, okay, let's try a different path. And so we try a different path over here. And so that, and you keep going, and you keep going, and then it says, and so on, right? Because it takes some time. And eventually you get this solution, and then you get a different solution, right? And the whole idea is available there. And then just for some more fun, you guys did code this up. You can go and in Python, you can go and code it up again if you feel like it. You can try something new. Cool. Printing unwanted ill data will output the cause test. Okay, cool. And so this is very similar to that of HackerRank. Cool. So I will link this below. Again, my laptop is literally dying, I guess. But I'll link this below, and we can y'all can have some fun with it. But that is basically my spiel on recursive backtracking. Here's some more photos that I tried to go and find for y'all. But that's backtracking in a nutshell, right? Let's go on to some of the more interesting stuff, and we'll get to memoization. I guess memoization is really important for factorial and for Fibonacci, which is very similar to factorial. Think about factorial is that when you get this 5, right, you have to get like 4, 3, 2, 1, and 0. You have to ask these questions, right? But what if you keep asking the same? Like, what if I say factorial 5, factorial 5, factorial 5, right? It would be easier for the computer to just have that like stored somewhere. Be like, okay, this guy keeps asking for factorial 5. Might as well just keep factorial 5 stored, right? And in order to have factorial 5, we need factorial 4. And so you keep all of this stored. And every time someone new asks a new question, like someone comes along and he's like, okay, I want to do factorial 6 now. Then you can use the past answers to get your factorial 6. That's the whole idea. And so this could be very, very, very helpful to speed up your program, because your program will, if you want factorial 6, you'll have to do this whole thing all over again. You know what I'm saying? And so that's the whole concept of memoization. Memoization we'll touch on in a little bit when we talk about dynamic programming. So catch me there if you want to learn more about memoization and how it can be used in dynamic programming. But let's jump back into recursive, the other things in recursion. So we got permutation, we got combination, we got subsets. So I guess the best way to go and talk about permutation is to go look at some code that is available on the website again. So let's go back to things, and then we can go to actual class notes. Great, gotta love the names, right? Then we go into, nope, that's the queens, and you can redo your assignment if you really want to there. So let's talk about permute. Permute, actually, let's talk about subsets. I think subsets is a good primer to permute, and that is available right here. So the idea of subset is that you have like this list of A, B, C, D, E, and you want to create like smaller lists and different combos of this list. So this is where your combination function could potentially come out from. Again, this is a recursive function, and we can tell it's recursive is because we have this over here. Okay, we got subsets and we got subsets over here. It's pretty cool, right? So the biggest thing that we want you to focus on is right here. Again, we've got our base case that says, hey, if low is equal to high, if low is equal to the length of the array or the list A, then we want you to print B. Okay. And then otherwise, and then return, one thing to just to know, this return basically stops the program, right? It like kicks it out, right? That iteration, that function call, that will return. Once you hit that return, it'll just stop, okay? So let's move on to the else statement. The else statement copies B, and so this is known, I believe, as a deep copy. I believe in Python, this will make a deep copy. A deep copy is basically saying that every value in B needs to be copied over into C. Okay, so that you're not passing around the same list. A good analogy to that is that imagine that you're working on like a Word document or like a essay with your group, with a group of people, and so you could make a Google Doc, right, in which you can kind of everybody can work together and everyone's changes will be noted into one area. Or you could send them all individual like Word document files. And then everybody's, uh, individual changes will not be reflected on one big, like common thing. It'll be your individual changes, your individual changes, and your individual changes. Now, using that analogy, you can see that this will allow us to actually have our own individual changes, because we don't want to have like one of the arrays or one of the lists that we're working with have like someone else come in or some other function call come in and like start messing around with it. Okay, we can talk more about that in some other time, but that's just kind of a little briefer of what this is kind of doing. So cool, we're gonna append this load thing, and then we're just gonna go at it. We call this subset, and again, I'm gonna try to draw how, like using my mouse, I'm gonna try to go around and how this is working. So we're gonna go over here, and then we're gonna go back up because it's gonna call itself, right? You just gotta follow it. That's how the computer does it. You should be doing it the same way, right? Go into here and you see your base case doesn't match the base case. Go into here, it gets called again, and it keeps going until it hits the base case. And then that base case lets you move on to the next portion over here, and that calls it again. And you can start to see this is becoming, it keeps doing it over and over again. So this is difficult. It's a lot of, it's heavily, there's a lot of computation. There's a lot of computation. And so for that reason, it could become slow sometimes, right? And so that's why we worry about efficiency. And again, that's where big O comes in, right? Big O, you want to see, okay, how many times am I calling it? Is it necessary to call it this many times? I mean, in this case, yeah, right? But is there a different way of doing it? Another thing about returning versus not returning, so we're just calling the function, and it's just going to keep going, and it's going to print B. If we returned it, we can actually do some other stuff with it. And so I'll leave that up to be an exercise for you guys to figure out how to change this so you can return all of the subsets in like a list of lists rather than, just printing them out. Okay, so I'll leave that up to y'all. So we covered subsets, and so that's very similar to combinations. We covered a little bit of normalization, we covered backtracking. Let's get to permutation, and then we can move on to the next video. So permutation, again, is available on this course website. You can go to this one. There it is. And it's the same sort of concept in which instead of, chopping parts of the list off and reordering, it's more about reordering in here. And so this is a way of reordering in Python. And then you call the permute function and you reorder it again. And then you call the permute function. And it's the same idea. And again, I would encourage you to go, rather than printing, do some return a list of all the permutations, right? Again, this is return versus printing is very important. It's an important distinction for everyone to know. All right, cool. I think we've covered everything that we can about recursion. Again, some really cool tips. Again, check out the study guide if it loads. And here you can see backtracking. How does it work? That's something that we want to cover. We want to look at coding back for recursion problems. We want to look at the end queens, and then also navigating a maze. The maze idea is very similar to, let's say that you started a maze and you have to get to the end. You have to get out of the maze, right? You're trapped in this maze. You want to get out. So you can try every single path, and you go down one path, you go down all the different paths, and you go in an order, right? You don't want to get lost, so you want to go in a sequential order, right? So you take path 1, and then path 1 splits into 2 paths, and we'll call that 1, and you'll take that, and then that path splits into 2 more paths. So you go path 1, 1, so on, right? You go like that, and then if you take that 1, 1, onwards, and you reach a dead end, it's time for you to go out. Go out one level, and then take 1, 1, whatever, comma 2, right? And then see if that reaches you. And then if it's a dead end, go back out one more. And then as you go, you'll keep moving level by level, right? You'll go like 1, 1, whatever, -1, whatever, right? You'll get through that eventually. And so that's the concept of the maze and backtracking. Pretty cool, and same idea with end queens. Pretty cool. I would recommend looking at Coding Bat and HackerRank, LeetCode. They're great places to actually learn up on more recursion, get your hands kind of dirty with it, and then backtracking is another way of recursive stuff. So I'll link this website. Study guide is very important. What else can you guys do? Past that, I think everything is basically it. Yeah, I think we covered recursion pretty well. Definitely ask more questions on Piazza, whatever you got to do, uh, and look at the different problems in recursion set 2, very important. Um, and yeah, I guess I'll see you in the next video in which we will talk about sorting, searching, uh, the different algorithms, and hashing. So let's get through that, and then we'll talk about stacks and queues in the video after. All right, I'll see you.